Welcome to shipcalculation.com. For any inquiry, you can email us shipcalculation@gmail.com, WhatsApp/call +62 821 1448 3491. Today topic is Kimpo's Crane Pedestal calculation. To continue this, you need to subscribe into our YouTube channel shipcalculation.com. Don't forget to subscribe so that you will get more information updated of this calculation. Okay, general, the calculation to be carried out conform the following items for provision crane post. Calculate stress to be appropriated conform with the criteria defined in the rules and guidance for the survey and construction of cargo handling appliance. The flexion of crane post caution by the bending moment to be with the allowable value recommended by the crane manufacturer is allowable inclination of deflection is 1 divided 600. So this is the allowable, you cannot more than that. Following load condition to be considered in this calculation is safe working load of the crane, shell weight of crane system and cargo fitting attached to this crane, shell weight of loose gear, and also load due to ship inclination. So design criteria for this ship trims is 2 and here is the 5 degree. Okay, this is a load diagram. This one is the crane pedestal, and then this one is the boom. Okay, the boom, this is the boom. So the center of gravity is here, so you need to determine the center of gravity, the height of the pedestal, diameter of the crane pedestal, okay, and then the thickness of the pedestal, the height from the center of gravity, and then the height of the boom here, got h1 and h2, right? So r2 from this radius is the center of gravity, and then r1 is the radius. So maximum slaving radius, okay, that's maximum slaving radius, r1. So this all this input you need to change, okay, depends on your crane manufacturer info. Okay, let's say that this one is the w1 is the safe working load including loose gear, right? So this one is to be considered additional impact load coefficient and work coefficient, so around 9962 kilonewton. And then the crane sail weight, so the crane sail weight is around 784.8 kilonewton. So you need to change this one, depends on your current crane pedestal. And then maximum slaving radius, is r1 in this one. So this is the maximum slaving radius. So here got getting is around 1000 centimeter, okay. And then this one is the horizontal distance between the center of gravity of crane and force center line. So this one, okay, you got the center of the pedestal, go to the center of gravity. So as long as you know the center of gravity your crane, you have to make the sketch like this, so that easy for you to do the calculation. Okay, so this one is the h is the post height, okay, is the post height, is a post height, this one h. So h1 is the vertical distance from the upper deck to the top ship, this one here, okay. Let's say this crane pedestal into this main deck, so the main deck go to this ship, and then h2 is the vertical distance from the upper deck to the center of gravity crane, so this is the one. So you change around, this one is 2000 centimeter, and then h2 is the 780 centimeter, okay. So the ship trim, just now we get the 2 degree, and then the ship here is the 5 degree. So depends on your phaser, Okay, you can change this one also. This one you can change, depends on your vessel. Okay, either 3 or 4, so just change. And then this one is the outer diameter of the crane post. You got the outer diameter, right? So outer diameter, and then how much the wall thickness. So diameter is 427, and then the wall thickness is the 3 cm. Okay, wall thickness of the crane post. This one is the additional impact load coefficient. So this one additional impact load coefficient, you can referring to the any classification rules also, or you can just go to the they call it the there's a recommended by the crane manufacturer. Okay, how much, but normally it's a 1.10 is for the lifting one, the lifting. So this is the general, the strength calculation of the crane post, right? So this is the general one. So this one you are getting from the above. Okay, from the above just now, right? So this one will be automatically, so you don't need to key in because you already make the input here on the red color one. So make the input on this, so you don't need to change here because this one is the automatic formula, right? Automatic formula. So the safety working load including those gear is around 200 tons. So the crane, this one able to take around 200 ton, around 200 ton. Okay, because yeah, we just consider that is the crane pedestal only. Okay, so the safety working load including those gear is the 1962 kilonewton, or this time is a 200 ton. Okay, so you just divide 9.81 maximum reach radius is 1000 centimeter, and then the crane weight is 784.80 kilonewton, or around 80 ton. So trim 2 degree, and then the height is of 5 degree. Combine this is automatic from the 5.381. So the crane post, okay, the crane post is also the same. So this one is the automatic from the above, so you don't need to change also, because the post height and then post diameter, post wall thickness is comes from here. Okay, the post height 1130, diameter diameter 427, and this one is the wall thickness 3 centimeter. So you don't need to change. Okay, section area is the automatic formula also. Section area for this pedestal. Okay, this is the size of the pedestal. So automatic formula, and then from the section modulus and getting the moment inertia. So these three items is very important one to determine or to know the strength of the profile. Okay, but you must understand about this, how to calculate the section area, how to calculate the section modulus, and then how to calculate the moment of inertia. The strength of the crane post, okay, this is the bending moment. So the bending moment got the formula also. So this one is the automatic formula, so you don't need to change anything also. This one is will become automatic, and then the transport also will become automatic. So all the input here will generate the formula, and then we get the result. So this is the getting the result. Okay, so this one is getting the result, so you don't need to change. Okay, and this one also the stress. So the stress and allowable is 11.75. so this one is below 11.75, so it's acceptable. And also the deflection. So deflection is the from the manufacturer is 1.0224, so it's less than that, and then it's less than that, right? So and then become like the become pass. This one is a pass, and then okay. So this pass and okay also will generate automatically. Let's say that the input you are put here maybe around 2 centimeter only. So you key in here 2, okay, into the thickness, right, 20 mm. So this one become fail, not okay. So you have to change, let's say 2.5, either pass or not, and this one will become pass. But this one is very close from the allowable. It's a 10.17. So you better get the pro to make it safety is 3. Okay, even though the auto diameter also, let's say you want to make it 300, also fail, not okay. So you have to make it bigger. So just now we make it bigger, is 427, 427. Okay, and then this one become pass. So whatever the input here, whatever the input here, is automatic generate either pass or okay. Okay, either fail or not. So let's say here you put maybe around 300 safety working node, maybe you put here 3000, and this one also become fail, not okay. So you have to reduce the weight, 1962. Okay, so just now I put here 3000. This one become 360 ton. See, 360 ton, but this one is a fail. So you have to reduce the weight, and then become pass. Okay, so this is how you are going to determine your clamp pedestal. Okay, your clamp pedestal before you make the any finite element analysis. You have to do the manual calculation first to determine how good your pedestal, how strong your pedestal here, because this one is depends on the height. Okay, so thank you very much for watching. Don't forget to subscribe our YouTube channel, shipcalculation.com. If you need ship calculation and ship design drawing, you might contact us. Email shipcalculation@gmail.com. WhatsApp/call +62 821 1448 3491. Office call +62 778 480 8127. You might visit our website also to get more video, www.shipcalculation.com. Thank you very much for watching. Bye bye.